All right, everybody, welcome back. Today we are going to be working with sixth grade, and we're going to be dealing with dependent and independent variables. Now, as you can look at this practice quiz that I have for you guys, notice I see a bunch of little calculators everywhere. Taking a quick glance, every single question seems to have a calculator for it. So, as a good habit, okay, let's go ahead and open it up. So here's my Desmos calculator. I'm going to leave it open just because why not? Okay, it just makes it a lot easier to do a lot of the work and check our mental math. So let's see what we're going to deal with. Just a little heads up, when we're talking about variables, right, we're talking about letters. That's it. It's a fancy word for letters, okay? And you can already see right here, I got letters right there, right there. I see a bunch of tables, right? I'm getting my head straight because a lot of these look very similar. And that means they're probably going to have the same style of questions. And we're going to be doing the same style of work most likely, okay? So I see a lot of tables, all right? So you can see, well, you got to practice, all right? Okay, so let's go ahead and get started. Now that I got my head on straight a little bit, I can kind of see what I'm going to probably be doing. So let's start with Jacob's family, who was able to get a food stall at the church fair this past weekend and decided to sell pupusas for a fixed price. So if you don't know what pupusas are, okay, you need to go find some because they're delicious. Okay, they're from El Salvador. All right. And if somebody just puts two tortillas with cheese in the middle, that is not a pupusa. That's a quesadilla, kind of. Okay? So, yeah, just a heads up, all right? The best ones are revueltas, which is basically pork and cheese. Unless you're like my wife and you like cheese and bean, okay? There's a bunch of other ones, but yeah, I'm getting ahead of myself, and now I'm getting a little hungry too. So just Google it and, find it out. It's really good, okay? Anyways, so let's see. So let P represent the number of pupusas sold. You get what they like to do here. All right. I have to use the first letter, right, of usually the words I have. And let M be the total. Right. And normally I'm like, why wouldn't they put T? The total amount of money. Oh, money. And notice how they have it in dollars earned. Okay. So let's see. For this one, we have to fill in the table for all missing values of P and S. So this is interesting. So, like I said, a lot of this is very, very, very similar, okay? So what we got to do is find the pattern. So normally we're going to say, how did I go from there, from left to right? How did I get there? So one of the things you guys can say is, well, technically I could have said, oh, that's 3 plus 6, right? But remember, the pattern has to be the same for all of these. So how do I get to that one? How do I get to that one? How do I get to that one and that one? They gave me one pair and another pair. Does 12 plus 6 equal 36? Well, let's check. 12 plus 6. Yeah, that doesn't work. So I can't add 6. It doesn't work out. So what's another way that I can get there? How do I go from 3 to 9? Well, if adding doesn't work, there's my plus. I can't subtract. I can't divide. Divide makes things smaller. So the other option is to multiply. So what do you think I can multiply by to get from 3 to 9? And this is where a bunch of you guys are good at your mental math. And you're going to be like, oh, Beltran, that's easy. It's 3 times 3. All right, let me just double check your mental math. 3 times 3. And that is, in fact, 9. I'm going to give you guys a little shortcut here. Okay, because it's the same type of questions, right? That's why I went over it earlier. How do I get 3? Well, let's think about it. These are the number of pupusas sold and the money collected. So for 3 pupusas, I got 9. Ew, that's a horrible 9, huh? I got $9. So think about what I'm asking you. How much was each pupusa? What would you normally do? And in this case, hopefully you're getting in the right mindset as me. Well, if I had $9, I'm going to divide that by the 3 pupusas. And I'm going to say, hey, Each pupusa is $3. So what's going to happen is that is your rate, aka unit rate. Hint, hint, for the rest of the quiz and the rest of your life, and especially in 7th grade. Oh my God, 7th grade, guys. When you get to it, it's the same thing. Okay? So, another thing that I like to call it, it is basically your rate is your multiplier. That's what most of you guys will remember. So 3 times 3 equals 9. Well, let's try the 12. Does 12 times 3 equal 36? So 12 times 3 equals, oh my God, yes it is, equals 36. So if I want to go left to right, I have to multiply by 3. So 6 times 3 equals, what did I get? 18. Let me double check. 6 times 3 is in fact 18. So 15 times 3 también. So 15 times 3, let's see, I'm going to put that on the calculator. 15 times 3 is 45. So I'm going to put a 45 there. And notice I'm doing a different color just so you can see which ones are put in there. What about the 27? That one's a little tricky, no? Because if I go to the right and I have to multiply, how do you think I can go backwards? So if I go to the right and I multiply by 3, what do you think you're going to do if you go the opposite way? What is the opposite of multiplication? Hopefully you're thinking like me. You're going to divide by 3. So let's see. 27 divided by 3, and I got 9. Okay. Let me double check. 9 times 3. Does that give me 27? Yes. So notice I filled out my whole table. Now, again, I'm going to spend a little bit of time on this just because I'm going to go faster on the other ones. All right. Do you see a pattern here? Can you tell that this is a pattern right here? 3, 6, 9, 12, 15. Can you see those are your multiples of 3? Another way you're going to see it is, hey, look, I added 3. I added 3 to get 9. 9 plus 3 equals 12. 12 plus 3 equals 15. And on the other side, you said, oh, look, 9 to 18. I could have doubled it, but in this case, I added 9. 18 plus 9 is 27. 27 plus 9 is 36. 36 plus 9 is 45. So it's a pattern. Some are going to be nice like this. Some are not. Just a heads up. Okay, all this stuff is connected. All right, I'm giving you a lot of stuff for 7th grade. Hint, hint. All right. So number 2. Miriam completed 10 math problems. Okay, see number 10. 10's important. Before dinner. She solved X. X is important because it's a variable. That's our thing today, right? It is not multiplication. It's a variable. More math problems. So if it's more, that means you added after dinner. Right? Oh, if you saw the last video or the first video of, what was the name of it? Algebraic expressions and equations. I told you guys, when they tell you to write an equation, you better put an equal sign. Okay? So write an equation that represents the total. And see, equals total math problems. And I have another letter of problems Y that Miriam solved. So what do you have? I like to do this right here, my little box. So I have a number 10. Numbers are always important. I have a letter X. I know that I have to add. I have to add something. I write an equation. That means I need an equal sign. And I have another letter, aka variable, which is Y. All right, so let's see if I can put this together. I'm going to read it again. Miriam completed 10 problems before dinner. So Miriam started with 10. She solved X more problems after dinner. So more X after dinner. Write an equation that represents the total number of math problems that Miriam solved. So if you started before, then after, then you get a total. And you're like, well, what's the total? There's no number, but there's a letter, right? They told me the total y. So in this case, that's essentially it. Did I use a 10? Yes. Did I have my x? Yes. Did I add something? Yes. Do I have an equal sign? Yes. Is there a y? Yes. So I could have said 10 plus x equals y. Now, the thing that's nice about the state exam, it's however you write it is usually correct. Well, let me rephrase that. As long as you have the same value in the equation and you write it differently, it's still going to be correct. What do I mean by that? So some of you guys maybe said x plus 10 equals y. Well, guess what? That's fine. Some of you guys probably said y equals 10 plus x. Guess what? That's fine. So as long as your equation is correct, okay, it usually doesn't matter how you write it. And you're going to get a few examples if you keep watching my videos, right, of different ways to get it. Because I know some of you guys think a little differently, which is awesome. It doesn't mean you're wrong. It's, you know, you just got it a different way. All right. Same answer, different method. All right. Next one. So Ronnie has a part-time job at his parents' business and earns the same amount of money each day. So whenever I see the word each, per, a, every, right, that is your rate. So miles per hour, 60 miles an hour, 60 miles per every hour, 60 miles a hour, an hour. Okay, that's your rate. So in this case, I have the letter D, the letter M, and you can see it right here. Okay. All right. So let's see do we see a pattern here? Enter the number, enter the total money earned after working 8 days. So where are my days? My days are right here. I got 1, 2, 3, 4, 5. Hey, look, that's beautiful. It is in order. That's nice. So this one, can you tell how much did you add every time? Plus 1, no. Plus 1, plus 1, plus 1. And again, habits, good habits. This is going to be especially awesome for 7th grade. And so on. I mean forever, okay? Anytime you have tables. So what do you think I should have next? I should have a 6, I should have a 7, and I should have an 8. So you know what? It's a little weird. So I'm going to write them right here. So there's my 6, there's my 7, and there's my 8. I want to make it neater, okay? So here I have 24. How did I get to that, to that, to that, to that? That's a little bit more annoying, right? What did I do on my first problem? On my first problem, I went across. So let's see if I go across. Excuse me while I wait for the bell to finish. Okay, so I got the pattern going down. Is there a pattern going across? Now we can add or multiply, so that's plus 23, but I can't add 23 to everything, right? It doesn't work. So 1 plus 23 gives me 24, but 2 plus 23 does not give me 48. So the other option is multiply. So how do I multiply? 1 times 24. That's 24. What about 2? So let's check. 2 times 24. Hey, that's 48. What about 3? So 3 times 24, 72. Yeah, hey, look. Get your pattern here. I'm going to just make sure everything's correct because every now and then they like to mess with us with just one of them being wrong. Times 24 is 96, so that's correct. And then 5 times, let me clear that, 5 times 24 is 120. So that essentially is how I go from left to right. So notice, which one do I only care about? I only care about 8 days. So yes, I could have figured out this pattern, which some of you probably did, right? And you could have said, hey, look, guess what? I just added 24 every time. Hint, hint. Okay. But some of you guys probably figured out this one. You said, hey, look, if I go across, I'm going to say 8 times 24. 8 times 24, and that's going to give me 192. So this is where I always tell my students, whichever method you use, as long as we get to the same answer, that's all that matters. And you didn't get lucky, okay? because we all think just a little different, and that's totally awesome. Okay, that's the best way to kind of look at math, all right, from all the different viewpoints. And it just goes to show you, right? Hopefully right now you learned a different way of doing, the same problem. And if it's easier for you, great. If your way was easier, just stick to your way. Okay? All right, next one. Consider the table below. Okay. Enter an equation. I better have an equal sign. And they gave me the equation, the way it's supposed to look. So enter an equation that represents the relationship shown on the table. Use the form y equals rx. And what did I say earlier? Where R represents the rate. In this case, it's the unit rate, aka your multiplier. And you'll see what I mean in a little bit. Okay, it's all connected. Big lesson here. So how did I go to y? This is where it's a little weird because you're like, wait, y is on the right. So if I flip these two, I can say that rx equals y. Okay. Well, do I have an x on the left side? Yes, I have an x. What did I do with the x? I multiplied times r, and I got y. Do you see where I'm going with this? What have we been doing with all these tables when we go across? How did I get to 6? I multiplied 1 times 6. How did I get to 12? I multiplied 2 times 6. How did I get to 18? 3 times 6. 4 times 6 equals 24. And I'm going to triple check just to make sure. 2 times 6, 12. 3 times 6, 18. Okay, I'm good. And then 4 times 6, 24. Perfect. So let's see what I have to do with my equation. What did they really want me to do? They wanted me to find the multiplier. So where's my rate? What did I multiply the x by to get the y? I multiplied by 6. So in this case, I'm going to say y equals 6x. And how did I get that? Because I said x times 6 equals y. Doesn't that sound easier, right? X times 6 equals y. And how do we do x times 6? It's a little weird, right? We usually write the number first, aka the coefficient. So we're going to say 6x equals y. And what did these guys want us to do? Like, okay, I went left to right. And what did these guys tell us to do? Oh, they just told us to flip the equation. So I put the y on the left and I put the 6x on the right. It's the same thing. But in this case, they want it in this order. Okay, so you have to copy the order. That's what's the key here. Okay, it's important. That when you copy the order, did this one matter? No. Okay, this one, yes. So you got to know the difference, right? Test taking strategies, guys. Okay, moving on. So let's see. This looks like another one, like the first one. So your school is selling burritos. Got to roll that R. Okay, burritos to fundraise for new sports and team uniforms. For new sports team uniforms. So I have my letters. You see them? I got B. There it is. I got M. There it is, and that's my money. So fill in the table. So notice, what have we been doing all this time? We have been figuring out 3 times what equals 24. 12 times what equals 96. So how do we figure that out? Well, to get the question marks, we just said 24 divided by 3. So let's figure that out. 24 divided by 3, and I got 8. So I'm going to triple check just to make sure, right? Because sometimes we do the work in our heads like, okay, I got a number, so I'm happy. It's a whole number, so I'm super happy. I didn't get a decimal or something weird. But let's check the work. 3 times 8. Did that equal 24? Yes. So now I'm happy. So now I'm going to assume that that is also an 8, but I'm going to double check. So 12 times 8, and that equals 96. Yay. So that means that all of these I have to multiply by 8 to go to the right. But wait a minute. I'm missing all the letters. Oh, that's not P, huh? It's supposed to be B. I apologize. It's B. So I got to find all those missing letters. So the question is, if I go to the right by multiplying, what do we say to go backwards? Instead of multiply by 8, I'm going to divide by 8. So the first one is 8 divided, let me clear that, 8 divided by 8, and I get 1. Then I get 64 divided by 8. So let me check calculator, 64 divided by 8, and I get 8. And then I got 120 divided by 8. So 120 divided by 8, and I got 15. So this is where you see the pattern, right? I got 1, 3, 8, 12, 15. There's no real pattern on this one, right? Whereas the other ones, they were kind of nice. See, 1, 2, 3, 4, right? This one was 3, 6, 9, 12, 15. They were the same pattern. Sometimes it won't be, all right? But notice the patterns we did find was going left to right or right to left. So that is one of the things I want you guys to grasp today, right, with the tables. There should be a pattern going across or going down, okay? And usually it's going across. Okay, another table. All right, let's see. Ethan is filling a container with water at a constant rate. Let T represent the time in minutes. Okay, T for time, that makes sense. That Ethan fills in the container. Let V represents the volume of water in the container in liters. Okay. So enter the volume of water in the container in letters. Well, that's liters. Typo right there. After 11 minutes. So let's see, is there a pattern here? Yes. Can you guys see the pattern? I'm going to fill it out right here. I'm going to put a few more. So it looks like I got 0, 2, 4, 6, 8, 10, 12, 14, 16. All right. I only did a couple. Where do I need to go to? I only needed to go to 11. So that means 11 is in between 10 and 12. Okay. So that's something to keep in mind, right? But I'm going to stick to the same pattern first. What about this pattern? So on the right, if I kept going, let's see this one. Hopefully you realize I just added 2. I added 2, I added 2, I added 2 every time. On the right side, I added 5. I added 5. I added 5. Can you see that? I added 5. So if I do that, my next numbers after the 30 on the right side, 30 plus 5 is 35. 35 plus 5 is 40. 40 plus 5 is 45. And 45 plus 5 is 50. So then here's the kicker, right? I want to know what it is at 11. Okay. So how do we change that up? So let's see what we can do here. What are some patterns? Do we see any patterns going from right to left? Well, 0, though I can't multiply anything times 0, so it's only 0 plus 10. Right? Because 0 times 10 doesn't work. But 2 plus 10 doesn't give me 15. So it can't be addition. It can't be multiplication. So is there another way to think about it? Let's see. So if I look at the pattern here, here's my language, super important language. So every 2 what? 2 minutes. So every 2 minutes. What happens here? Every 2 minutes, you add 5 liters of water. Interesting. Do you see where I'm going with this? Because I don't want every 2 minutes. I want to know the 11, right? So that's not 2. That's 1. So what do you think I should add then? Instead of plus 2, if I do a plus 1, every 1 minute, how many liters should I have? Well, if 1 minute is half, of 2, then I should have half of 5, which is 2.5. So now I'm going to go and say plus 2.5 to get to the 11. So 35 plus 2.5. And that's going to give me 37.5 liters. So hopefully you could see that. Okay. All right, next one. Sarah buys N notebooks, so I see a letter. Each notebook costs that amount of money, so there's a number. Write an equation, I better have an equal sign, that represents the total, see there's my equal, of T, there's another letter, of the notebook Sarah buys. Assume there is no tax. So what do I have? I have an N. I have 2.75. I have an equal sign, and I have a letter T. Did I have to add everything? No. What did I say at the beginning of this lesson? Okay, a lot of words right here. It is your rate. Rate, we said, is your multiplier. So if I look at this, an equation, I have N books, and each book costs $2.75. I'm going to give you a huge hint. Let's see if you can follow this. Okay. And you don't have to copy this. If I'm buying a burrito, it was $6 per burrito. It was $10 per every lawn that I got. I made $15 an hour. It was $2 per hot dog. It was $6 per drink. So do you see what I'm going with this? What did we have here? It was $2.75 per notebook. So that's my multiplier. That's how much each notebook costs. So if I multiply my notebook times 2.75, I should get my total. So do you have an equation with everything? Did I use 2.75? Yes. Do I have an? Yes. Do I have an equal sign? Yes. Do I have a T? Yes. So notice it is 2.75 N equals T. Do you guys see a pattern here? I'm going to go through this quick. Favorite equation in 6th and 7th grade. Y equals RX. You're like, wait, that doesn't have it there. But if I flip it, can you guys now see Y equals RX? Can you guys see here? The left side is X. The right side is Y. And what did I do with my X? I multiply by 3. So Y equals RX. Oh, pattern here. Look, Y equals RX. Y equals R times your X. It's the same. Okay, with multiplying. So just a heads up, right? Hopefully you got that. If you didn't, it's okay. Just stick to your pattern. But I like to throw that in there just in case you guys get a little bit more difficult in questions. All right, Emily is buying some meat at a grocery store for this weekend's barbecue. They sell the meat by the pound. So by the pound, that is your rate. So P is the number of pounds. T represents the total price of the meat in dollars. Okay. So fill out the missing table. This is literally the same thing. Oh my God, this is not C. It is T. Okay, typo. All right, so let's see. How do we figure this out? Same idea. How did I get there? Well, what have we been doing to find our rate? We've been dividing. So 9.2 divided by 4. So 9.2 divided by 4, and that gave us 2.3. Let me triple check. So 4 times 2.3. Does that give me? Yes, it does. All right, so now I have my multiplier. I am going to have my letter P, and I'm going to multiply by 2.3 to get the total price. So 2 times 2.3, 10 times 2.3. And if I go backwards, I'm going to divide by 2.3 and divide by 2.3. So let's start at the beginning, calculator time. 2 times 2.3, and I get 4.6. All right, now I have 13. So 13.80. And I go backwards, so divided by 2.3. Hey, look, I got a whole number. So that's looking good for me. All right, then I go the other direction. So I'm at 10 now. So 10 times 2.3, and I get 23. And then finally, I got 27.60, and I go backwards. So divided by 2.3, and I got 12. I'm going to triple check. 12 times 2.3, 27.6. Beautiful. 6 times 2.3, 13.8. Awesome. So now I am happy with my answers. Okay. All right. So by the way, can you see the equation here? I wrote it on top, right? We can just write it the way you see it. So 2.3p equals t. Or can you see y equals rx? Your r is 2.3. Can you see that? Just thought I'd throw it in there just in case they ask you for a part 2, hint, hint. Because some of you guys are going to get like an extra level, like higher, if you're really getting this, right? If you're super like on top of it, they might ask you a part 2. Write me the equation. So there it is, okay? And your equation is usually y equals r. Ew, no, I guess that's all. What is that? X, okay? Same strategy, same style, okay? All right, so Desiree earns $8 for every lawn. Oh, there's my rate. So what do I have? So I have an 8. I have a lawn. So there's my L. I have an M. I'm getting ahead of myself. Let me read it. So $8 for every lawn she mows in her neighborhood. Write an equation. So that means I need an equal sign. That represents the total amount of money. There's my M that Desiree earns for mowing L lawns. Can you see my equation? What have I been saying? Y equals RX. But in this case, my Y and my X's are different, right? So what did I say earlier? All these words right here. $6 per burrito, $10 per lawn. Okay, $15 per, I forgot what those words were. $2 per hot dog, $6 per drink. This one I am making, or Desiree's earning, $8 per every lawn. So I'm going to write that as 8L. So there is my two letters. My letter and my number. Now I need an equal sign. So notice, hey, look, 8L, 8L. Those are my multiplying. Okay, the number and the letter that I'm multiplying. So I need an equal sign, and my other letter is just M. So M equals 8 times L. And again, you could have said 8 times and then the letter, right? Like, because they don't have it. So maybe on your thing it says, because it'll say M. And then you can put, do they have it here? Equals, right? 8. And somebody else can put times L. Do you see that? That's how your calculator, it's the same kind of thing for the keyboard. But if you don't want to put the multiplication, you could have just simply put 8L. It is totally correct. Either one. So you could have said 8 times L, or you could have said 8L equals M. It's the same thing. Okay. The other one was very specific where it wanted Y equals RX. So it had to be in that order. This one did not. But again, this one is our equation for 6th and 7th grade. All right, this is the last page. Yes, okay. Another table. So let's see what we got here. The following table shows the total cost incurred by a company for different hours of machine operation. So there's a total cost and hours of operations. Okay, and notice I got smaller. So if I got smaller, I probably have to subtract or divide. And we haven't been subtracting or adding, have we really? It's been multiplying and dividing. So let's see. Two employees try to determine the equation that represents the relationship between the total cost and the hours. So let's see what employee 1 does. Employee 1 said that the cost, so notice, the cost equals the M plus H. So what did the employee do? How did the employee find the M? Well, the employee started with this one. So the employee said, oh, I'm going to take the 413 and then I'm going to subtract the 18. Does that make sense what employee 1 is doing? I mean, it does, right? So 413 minus 18, and that gave them 395. So that means if I say minus 395, does that equal 18? Yes, it does. But remember, it has to be the same thing for everything. Minus 395. Minus 395. Minus 395. Let's check the work. So 575 minus 395. Oh, that does not work. That does not give me 25. That gives me 180. So right away, what can we tell about employee 1? He's wrong. So let's see. This looks like a super long one. Employee 2 is doing that. Let's see my answers, though. Which statement accurately identifies the correct employee and fully explains why the other employee is incorrect? So first of all, I know employee 1's wrong. So employee 1 is not correct. Employee 1 is not correct. So it can't be A or C. I just eliminated 2 answers. Again, test-taking strategies, guys. So my only option is it B or D? So employee 2 has to be correct. The reason is why. Why is employee 2 correct? So let's see what employee 2 does. Okay. So employee 2, I'll do a different color here. Employee 2 said C equals M times H. So employee 2 is the second set, okay? So employee 2 said, I'm going to take the 575 and I'm going to divide that by 25. So let's calculator time. 575 divided by 25. And the answer was 23. So what does that mean? That means that for M, it was 23. So in other words, 23 times 25 gave me 575. Does that work for all of them? So in this one, I'm kind of going backwards, right? So 18 times 23. So let's check. 18 times 23. Oh, there's a typo. Oh, I got to fix that. So 14. Okay. So that one is correct. Or it should have been. Sorry about that. Let's try the second one. 25 times 23. Yeah, that one's correct. If we go this way, 34 times 23. So let's check. 34 times 23, 782. That one's correct. Then I'm going to have 42 times 23. So 42 times 23, and I got 966. So in this case, can you see that, yes, employee 2 was correct, but why? So employee 2 is correct because employee 1 switched the hours and the total. So did employee 1 switch those? Would that have mattered? Would that have given me 23 as an answer? No. So employee 2 is correct because employee 1 did not use the correct equation. And again, what have we been seeing today? And this was a big, ginormous hint, right? Y equals RX. Do you see the pattern here? Your total equals your multiplier times your letter. So Y equals RX. So they just switched it, okay? All right, last one. There it is again, y equals rx. So select all the relationships that can be modeled by an equation in the form of y equals rx, where r is a rate, x and y represents quantities described. Okay, so remember y is your total, and x is like whatever you're using, right? That's like, it goes with the rate. Okay, and notice it's a select all, so you're not going to pick 1, 2, 3, or 4. Let me see. How many should you think you should pick? Do you think you're going to pick only one option, 2, 3, or 4 options? Well, if it's not going to be 1, because if that was the case, it'd be multiple choice, and it's super ridiculously rare to pick all 4. So you're going to pick 2 or 3, okay? Again, test-taking strategy here. So let's see. What's the relationship between the total cost of apples and the number of apples and the number of pounds of apples bought? So my total cost, so there's my cost, equals the number of apples and how much it costs per pound. So apples per pound. You see the language here. Apples per pound. Yes. So that one is y equals rx. The ratio between the amount of paint needed and the area of a wall being painted. So this one's a little tricky one. All right. So how many of you guys have been to the hardware store with a parent or by yourself? Well, that'd be weird by yourself. Parent, some kind of guardian, okay, probably an adult, and you went to go get paint. If you really get a paint can, it'll tell you how much the square footage is that the paint will cover, okay? So they'll say something like, oh, this gallon of paint will cover 50 square feet. So in this case, we have the relationship, which is the amount of paint needed. So that's your total paint. And then you have the area of the wall and the, like, let's just say the gallon, right? So every gallon gives me a certain area. So I'm going to use how I'm going to paint, whatever the paint I'm going to use has to do with the area times the gallons, okay? So that's going to be the total paint. So yes, that works. The ratio between the amount of water in a pool and how many times you can do a cannonball into the pool. Does that relationship make sense? So how much water is in the pool and a cannonball into the pool? Does that go together? Yeah, no, that's not it. And again, I already got 2. So this, I'm like, if I had all 3, I'd be done, right? Like, I'm sure there's 3 that I'm done. I'm not. So let's see if the last one's a 50-50. The relation between the weight of a person's luggage and the distance they traveled. So let's see, weight of a person's luggage. So is there a relationship there, like per cannonball? So per luggage? Does that make sense? No. So distance equals like person per, like weight per luggage. That does not work. The weight of a person's is the distance per, no, that doesn't, yeah, that doesn't work either. Okay, it's not affected. Okay, they're going to travel the same, right, if their luggage is 10 pounds or 50 pounds, okay? The only thing is, if you never traveled on a plane before, if you're over the limit, they'll charge you more, but you can still travel. So in this case, it was just the first 2, okay? All right, so that is it for this one. Hopefully that made a little bit of sense, okay? And you got some things cleared up for you guys, and you saw the pattern today, which we got to see y equals rx a lot, okay? All right, until next time.